Hello everyone and welcome to a new discussion. This is the second last discussion of this 60 lectures 30-hour course. And in this one we are going to discuss two main topics which are generally they do not find space in literature, neither in softwares, but very important one. The one is on the that is errors in GIS, and the other one is the key elements of maps, because ultimately one has to create outputs, and outputs in GIS generally in form of maps or charts. Maybe sometimes we have to create some figures or tables, but mainly maps. So, what are the key elements of maps? What are the things which we have to take care while creating these outputs? This is what the discussion we will have. So, let us start first with the errors in GIS. This topic is the least discussed in literature, and therefore, people do not take it sometimes seriously, especially the beginners who just started the using of GIS. So, for them also it is very, very important. Nonetheless, two important terms which are here which we must understand along with the errors in GIS. One, the precision, and precision basically is a statement of smallest unit of measurement to which data can be recorded. So, precision depends on the scale which we are using or the instrument which we are using. And I can give you an example from our day-to-day life, like if we are having 1 foot scale. On one side we are having, generally this is what the practice is, at least in India, that on one side you would have inches, another side you would have centimeters. So, you know that against 1 inch there are only 10 divisions, but against 1 inch it is 2.5 centimeters and 25 divisions, because it is 25 millimeters. So, obviously the centimeter scale on the same foot or scale we are having which is having more precise or precision. So, precision is a statement of smallest unit of measurement which can be done or recorded by an instrument. And another term which is accuracy, people many times take it synonymously, which is completely wrong, because these two terms are completely different. As you can see that accuracy is a statistical concept. Basically, it says that it states that the likelihood or probability that a particular set of measurements are within certain range of true value. If you recall your schooling days, and especially the physics experiments, our teachers used to say, measure or do this experiment 5 times, then take an average. So, an average, that is the statistical, and then we say that, and sometimes the teacher will say no, your values are very far from the real one, because they have measured by using some other techniques. So, this is a statistical term, and which basically indirectly tells us that how accurately we are doing the measurement. But the measurement which we are using, a scale or a sensor or a system, will have its own precision. So, two terms, precision and accuracy, very relevant in errors and GIS discussion, but completely different. So, should not be taken interchangeably or should not be used synonymously. Both are different terms. Now, as you know that in case of like accuracy, that we say that it is accurate by this percent or maybe with some units also. So, it may fall within 5%. So, that how far away the mark which I have determined after doing 5 experiments or 5 measurements, that you are describing by accuracy, and how well you measure is described by precision. So, our measurement, because we are using a scale or a instrument or a sensor, so that will control my precision, and how accurately I will do that thing, that will decide my accuracy. For example, many of us must have played this dart game, D-A-R-T, dart game, and in this you know, there are circles sometimes for the shooting also, or these other sports. These kind of targets are used, and as you can see that in the first one, that it is accurate and precise when we are hitting in the inner circle, and that means in that red part or red circle. Whereas in the second example, the one which says not accurate but precise, because precise is that because all our markings are almost in the same area, but because not accurate, because we are very far from the center point or bullseye, we also say in short. Whereas the third example is not accurate and neither precise, because all our hits are scattered all along these circles, and they are quite far from the center point or bullseye. So, sometimes we may be accurate but not precise, and many times we may be not even accurate and not precise. So, one has to be very, very careful that if you are precise, that does not necessarily mean you are accurate. However, if you are consistently accurate, you are also precise, like in the first example. Now, you know, in GIS, if we talk in terms of GIS, that maps and other data which we used in GIS are obtained by measurements in the many times in the field, or maybe employing some sensors like remote sensing, or maybe some laser based sensors. So, and therefore, inevitably these data sets which we will be using will have errors, and these errors, as you know also in GIS, which we have discussed several times, that error propagates in GIS. So, even no matter how small error is, we must understand one, and we try to manage that error so that it does not propagate, because a small error in the beginning may end up in a large way, and our modeling ultimately or our output may have large errors. So, that people will not accept. Our level of confidence will also be quite low if our data or our analysis having errors. So, we must take care about even a error is small that we know, and this is why I have mentioned that the GIS users need to understand inherent. So, their errors can be of two types, that inherent errors, that they are inbuilt basically with the data, and sometimes we have to use the data because we ourselves cannot go in the field and recollect the data as some organizations have already done. For example, if I use the survey topo sheets, like in India, Survey of India is the organization which prepare the topo sheets for us. But if it itself is having errors, which is having inherent errors must be there, so that we should have the knowledge of first inherent errors and the errors which are operational errors, which are under our control. And of course, if these errors are there and they are not contained, then these will propagate in our output. So, this point I have already mentioned, that errors in GIS are perhaps one of the least understood aspect and also least discussed aspect. Many books on GIS you would find they do not have in a chapter or a paragraph for errors in GIS. And of course, the software manuals or online help will also not discuss about errors. So, how to detect errors, while especially the operational errors, that will come through our experience and focusing on that also, that we should not ignore even there is a small error, and we should keep checking. That is why I have said in one of the rules sort of GIS, one of the rules of GIS is that after each and every step check for errors, because error propagates in GIS. Now sometimes you have to live especially with inherent errors, that it is not possible to remove all errors. However, a GIS user must try to manage them and should kept at the acceptable minimum, because if it becomes large, people will not accept our outputs. Further, we have to also understand what are the which are the loopholes or leaking points about the errors, sources of errors in GIS. So, first one is the errors in source data. These we will put in under this category of inherent errors, because we take lot of data from outside, and nowadays lot of organizations are preparing data and providing which are completely compatible with GIS platforms or GIS softwares. If they do not declare that what kind of inherent errors are there, then definitely they are keeping users in dark, and we may not be able to tell that how accurate our analysis is. So, we must explore that possibility, and that is why while discussing the sources of digital elevation models, I also discuss again each digital elevation models which are available free of cost, the associated errors, and most of the good portals will always declare in their metadata files that this kind of error is there. So, we must be aware about. So, these errors in source data can be positional errors or can be geometric errors, or maybe errors in case of digital elevation model about the z-axis. Now, sometimes we get an output, already prepared output of remote sensing data, maybe a vegetation index map or maybe a land use map prepared by some organization. They might have used some automatic methods for classification. So, a classification will always have some errors. No matter if I am doing, I will create, but if I am using somebody else classified image data, I must know what kind of errors are there in that classification. In the field also, field data sampling, measurements, ground control points errors, georeferencing errors, they will be always there, no matter how small are they. Now, second source of errors in GIS is occurring during data input. You know, in earlier times when lot of data we had to key in using our keyboard, type the data, and during that time lot of errors can come. Also, we used to digitize a lot of vector data sets. So, digitization will also bring errors. So, if even today we have to do it many times. So, if I do the digitization, then there can be mistakes by the operator, or there can be errors ultimately in form of errors because of my screen is not having very high resolution. That will affect the precision. Or when we used to have digitizers, still some organization use the digitizer. So, if digitizer itself is not very high resolution or not precise, then it will wrongly record the data. So, during input stage errors can come. Errors in attribute data entry, when we have to key in the data using keyboard, at that time also instead of just typing say 1000, we just left with 100 or maybe 10,000, and that will be error. Now, errors due to wrong band identification of remote sensing data. This happens many times because now we are not talking about 3 bands or 4 bands, we are talking about 36 bands, 38 bands, and even in hyperspectral remote sensing we are talking about 256 bands. So, if we have to handle so many bands of remote sensing data, then we must take care about that we should not wrongly identify band, because each band is representing different part of EM spectrum. So, therefore, the identification of bands should be also very careful while bringing into our GIS database. Now, third types of errors in GIS are data in storage. Errors that due to limited precision. I was supposed to type say 100.58 and I just left 100.5. So, with wrong precision, if I am not providing, it will carry the error. So, due to limited precision with which coordinates and other numerical data are stored, especially this precision issue will come with the coordinate. So, precision means here that to how many places after decimal we will keep the data. Format conversion, because any conversion from one format to another, while discussing vector to raster and raster to vector, I also mentioned that these conversions are not fully transparent. That means, whenever you convert from vector to raster or raster to vector, you will introduce some errors, and these errors may create wrong outputs for you or erroneous output. So, whenever we are doing format conversions, we have to be very careful that we keep the errors at the minimum. Now, fourth source of errors, that is the data and during the data analysis and manipulation. So, when we are doing the analysis, if we are not taking care, we may introduce some errors in our results. For example, propagation of errors during map overlay, because when you are doing map overlay of multiple vector polygon maps, for example, then the result a map will have hundreds of polygons, may have, and then if something is wrong in one of the input maps, then the error will propagate in my output map. Errors due to incorrect use of logic or equation. When we use these map calculators and try to perform these overlay operations even on the raster data, if we have not put this logic or equations correctly, obviously we will have wrong results. Now, errors arising from interpolation, because interpolation will always introduce some errors, especially when it is doing extrapolation where observation inputs are not there. So, we have to be careful that how much extrapolation a map is having, a surface is having. And the final one is the errors in data output and application. This is the fifth source of error. Now, that means the cartographic errors due to the limitations of output devices, that my output device does not have a high resolution, and therefore, it may create, though up to analysis I have done everything on a very high resolution, but output is on the coarse resolution. Incorrect or inappropriate application of GIS product. There cannot be a application of GIS, but unnecessarily we are employing GIS to create certain products, and that may also bring errors in our outputs. So, there are various sources of errors. Now, here as I also touched that this detection of errors will come only when we start using GIS extensively, that means through experience only. But if you follow that rule that after each and every operation in GIS, I will be checking errors, and if found, I will try to minimize or remove errors at that stage and will not leave for others to remove. That will allow us to maintain the errors or to their minimum level. Secondly, we must learn how to detect errors, and that by whenever you get a data set from any source, how reliable that source, we must apply our intelligence and try to check the data. For example, if I have to check my georeferencing, then I can check now using Google Earth, and assuming that Google Earth is the standard one. So, georeferencing errors can very easily be checked with Google Earth, that I will export my output file, whether it is a vector or raster, into KML or KMLZ, and then I will try to overlay over Google Earth, and if it fits where it is supposed to be, then that means my georeferencing is accurate. So, similarly, for many other operations, we have to invent our own way of checking errors and managing errors. So, therefore, it is very important, because the reliability of output will tell that how best the GIS works and what GIS can produce. If outputs are having lot of errors, people will not accept easily. Now, the second part of our discussion is that what all good maps should have. Very basic things, but again these are not discussed in the books, neither by the softwares, neither helplines. Generally it is not discussed at all, but these are very important things because everyone does not have the training of cartography. So, basic concepts of cartography, if they are applied in GIS, then we will not have that problem. So, regardless of cartographic style or content, most maps should have the following common elements, and I call them as map elements. Map elements, that these are the golden rules of cartography. The first one is the title. Each map should contain a title. Generally we bring the title at the top, and that title should easily identify as what is the map is containing. It should also include a little descriptive text as the location and purpose of the map, and that may go as a caption of the figure or map. So, title of map and captions both are required, then it will be a complete map. Now, after this title usually is the largest font size of all lettering on the layout. However, it should not dominate the map graphic itself. That means the size of the text which we are using for title should not be very large. So, one has to be optimize the size, and if the map is thematic, generally which are in GIS, the theme should be included in the title. For example, land use map of the study area of this 1990. So, we have declared in the title that this is the land use map of that area, and the year also it is inbuilt in the title. And the title may or may not be in a box, because that does not need to be at the top of the page, though generally this is the practice which people follow. But if space is not there, sufficient space for the title, we can bring the title in other positions, but generally it is kept in the top. Now, the second map element is the scale, and this scale indicator is very, very important, and one should not use the ratio scale, because if I use a graphic bar or scale bar and saying that this is 0, this is my 10 kilometer, if that map is reduced by the publisher or by anybody during photocopying even, the scale bar will also reduce accordingly, and there will not be any error in the scales. But if I write that 1:20,000 and a map is reduced, that the number 1:20,000 will not change. So, that will depict completely wrong scale. So, ratio scale should never be used in GIS. Always use the graphic scale bar. Because the reader or user of those maps should determine the relationship between a unit of measure on the map and a unit of measure in the real world. For that purpose only we are having a scale. That, for example, if scale is 1:, like for a topo sheet 1:50,000. So, here what it tells that 50,000 units of your map, 50,000 units of your ground are equivalent to 1 unit in map. So, that the real world has been reduced by 50,000 times, something like that. But in case of a scale bar, there will not be any problem. So, as the map is reduced or enlarged or projected, the scale bar will also change accordingly. Now, third element may not be that important, but it should be discussed, the orientation. Orientation of a map should indicate which way in the north is. That is most important, because if sometimes if my study area is in a way that if I put in a portrait, then it becomes very small in my printout. So, I would like to make it in landscape, and therefore, I might be requiring to rotate the north. So, we must take care about this orientation part of my map. If north has been rotated, it must be mentioned. Even if it has not been rotated, it must be mentioned. So, north, putting a north symbol is always a essential part of a map. So, this is done, as you know, by using a north arrow or a compass rose, and orientation may also be shown by graticules or grid marks through a grid which is latitude longitude grid. So, even if you are having latitude longitude grid or marking on the boundary of the map, margins of the map, still you should provide the north symbol, because as I have just mentioned that the convention that the north is always on the top page, but if space is not there, does not matter, it can be put elsewhere also. But normally people will put in the top side of the map, maybe on the left side or not, right side, does not matter. Now, the fourth key elements of map is the borders, or also in some software literature you may find a different term which is called neat line. So, border basically identifies exactly where the mapped area stops, that decides the boundary of the work or study area, and the border is often the thickest line, like title is having the largest font size, same with the border. Border is having thickest line on the map and should be closed on the edges of the mapped area. So, you are having basically a box. Now, this distance between map and the border should be the same on all sides. That means the border should be in a balanced position, and there can also be border around the entire map layout. That means enclosing all groupings at the title, legend, text box, etc. And both of these borders, generally it is always that only one border should be put that defines that this is what the area is, and inside that everything can come, title, legend and other things, even north symbol, scale, bar and other thing. So, both of these borders are sometimes referred to as a neat line, and in addition there is sometimes a thin additional line just outside the border, and this may be accounting and ideally making it more visually appealing. So, that is part of the decoration. I would prefer that one should not spend much time on decoration, but one must spend time to keep all essential elements of the map before printing, and also should always focus on the accuracy part. Now, the fifth key element of a map is the legend. Now, there are two terms people use sometimes interchangeably. One is legend or another one is index. So, a legend defines the symbols or colors including shades of grey and patterns used on a map. So, index you use generally, but there is no sort of written explanation or rule is, but legend is used when you use the boxes or symbols or colors for depicting certain areas, especially in polygon maps. But index is used when you are having line data, polyline data, point data. There you use the word index. But even if it is interchangeably used, it is not a big problem. Maps do not, because sometimes both things are together, legend and index. So, why to create two different titles, that one is legend, index? Basically, legend is also index. So, maps do not need legends if the symboling is not common, and simple as to be easily understood by the reader or by the user. See, though there is a lot of standardization of the symbols or symbology which is used in maps, especially the many softwares have implemented symbols of USGS, United States Geological Survey, which includes all kinds of symbols. But those symbols may not be used in different countries. So, basically there is no standardization or there is no word agreement for symbology. Nonetheless, one should try to use symbols which are easily understandable to the users and should be logical as well. And however, it must be clear that each marker or line type, weight and pattern represents. Because somebody may be using different line types, dashed line, dash point, dash line, a thick line, continuous line, and how thick and thin it is, and what is the pattern. Because for many geological representations like thrust or faults, we use different symbols along a line. So, these things must be taken care, whether if it is north dipping thrust, then the arrow or the triangle should be indicating towards the north. And legend does not need to be labeled legend. There is no need because it is already there. So, the more complicated the symbology on a map, the more important the legend becomes. How people will read? They first have to check, like if you go through a survey of India topo sheets, in the bottom right and bottom left, it is full of legends. So, it tells all the symbols which are being used in topo sheets. Though sometimes those symbols you may not find, no feature you may find which is shown in the legend, but these legends in say 50,000 scale topo sheets are common throughout all topo sheets. But here in GIS that may be a different scenario. What the purpose here is, whatever present, a red line present, a red and dashed line present, a circle is present, a triangle is present, or a color filled polygon is present, or a symbol filled polygon is present, the reader must know what these things are being represented, for what these are there. So, that one should be there. Colors generally we should use again carefully, judiciously, that for example, if I am showing a dense forest, then I should not show in red color or grey color or brown color. Then a dense forest should always be shown with the green color. So, these basic concepts one must remember. Another an important one is the map credits of any map element or any map. If I have taken map of somebody else, I must provide the credit. If I have used the data of somebody else, then I must mention that one also, maybe in the caption, or preferably if there is a space and the map is not getting cluttered, within the boundary or within the neat line we must mention that what is the source and to whom you want to give credit for that map. Because many times we ourselves are not creating maps, we are using somebody else created maps through some publications, atlas, or even from websites. So, we must provide that source from where this thing is coming. If it has been created by ourselves, no problem. That means the data has been collected by us, everything analysis has been done by us, and final maps have also been prepared, then probably you do not require to give credit. But if many things have come from other sources, the credit must go, otherwise it will fall in the plagiarism case of cheating or copying. So, source of data that will also save you, and that especially on thematic maps. If I am taking the say contour lines, then I must mention that these contour lines are coming from survey topo sheets. If I am using some forest cover information, I must tell that it is coming from there. And for large maps, generally this is also a practice that who has prepared that map, the cartographer, name of the cartographer is also mentioned. And other good practice is to put the date. So, we would know when it has been created, because these are, though may sound very small suggestions, but sometimes these becomes very useful. And therefore, one should keep remembering all these things. Not only the when map has been created, but the source, the data, age of the data if possible. That will also help many people, those who would use your outputs, that what was the time of the data collection. And then projection, because this is one part or one information which is generally missing, in which projection your map is, because there is no standard one and each country is having their own map projections. So, if I am preparing a map which is covering many countries, I must mention, even if it is of my own country, I must mention, because in GIS we can change from one projection to another quite easily. So, the projection information should also be there, that this map has been projected to this end. Now, another important one, that if I have prepared a report, then each map should not have a inset map or locator map, but at least the first map should be having a locator map. It will tell us that which is my study area, say within India. So, you just put the boundary of India and boundary of states, and within that you may show in form of box, and that locator map can go inside that your neat area within the main map in one of the corners. So, this locator map or inset map is required. If a map like Whatcom country should be an inset map of Washington showing the location of Whatcom country. So, this is what is that if I am working say in part of Uttarakhand, then a map of India and which boundary of Uttarakhand are also shown, or all state boundaries, and then through a box I should show that this is my study area. Another important key element of my map is this effective graphical design. Many times it is on individual choices, but I would suggest that whatever the design you follow, or whatever layouts you use it, one must take care that there should not be cluttering. Unnecessary information should not be put, but essential informations or essential elements should not be de-emphasized or avoided, because people will accept or appreciate if map is having accuracy and all required information. So, a person may have produced a very nice looking map, but it might not be having say north symbol, it might not be having a scale bar or a legend. So, what is the use of then that map? So, a good map in my opinion is always should have all essential key elements and should not be cluttered with the information, because neatly drawn, it should be neatly drawn, appropriately and consistently generalized, and of course symmetrically balanced. That means on one side within the neat line or within that box, it should not be cluttered in one corner. So, there should be balance of font sizes, balance of color, balance of shading, everything one should. That means while preparing your output, no matter how much time you have put while doing analysis or field collection, data collection, if your output is wrong or output is not good, no one would appreciate your work. So, everything, your data collection, your data analysis, and finally maps or your output should be also up to the mark, and without, as I have already said, that without unnecessary cluttering of the map. Keep it simple. The way artist details. So, we vary of the artist. Do not make your map cluttered with lot of information, lot of colors, lot of fancy symbols. These will not be appreciated at the end of the day. Now, the ninth one in this key elements is the visual hierarchy. Means whatever we wanted to convey through our maps, that should have the more weight. So, obviously the user should see that one first. If I am, say for example, if I am keeping very large or red color title for my map, but whereas my map is in a very small size and index map is very big size, that means the balance is missing. So, visual hierarchy is also not followed. So, a hierarchy of symbology should be used for the lettering, that means writing, line weights and shading. And more important features are typically larger. Whatever you want to emphasize or whatever the important thing you should emphasize, and the other informations which supposed to be there should be there, but they should not be emphasized too much by creating their large size or having some fluorescent colors or attractive colors. And at the same time, do not overweight or underweight features. Therefore, that means the balance is required, and that one will learn only through experience and seeing others' work also, especially the published one. So, if those who are in the research domain or education domain, they can see the publications of people, how they publish. And one more point here is the purpose. For what purpose that map has been prepared. So, all maps should have a purpose, and we should influence every element of the map and the map layout. And one should be able to clearly articulate the purpose of their map and should keep the audience or users or the client who the maps is being produced for. So, one should keep the target, who is going to use my map, what is their background, and how good my map should look. So, if it is not looking good for myself, then you can assume then others may not appreciate. So, very neatly designed, very balanced one, and emphasize the point which is your real output. Rest you can keep because they are supposed to be kept. So, if you take care about errors in GIS as we have discussed, and also take care about the map elements, one can really produce very reliable and very good outputs. So, with this I end this discussion. Thank you very much.